Hello, I'm DJ Rao. This is the second part of the five-part series designed to provide a rapid introduction to concepts in C++ so that programmers who already have some experience can quickly ramp up on developing programs in C++. Ensure you view the other four parts of this tutorial series that covers the core concepts required for developing comprehensive solutions in C++. This part of the presentation focuses on parameters and function calls and is possibly one of the most important presentations in this series. Functions or methods are integral to all programming languages. They streamline the use of code or logic, and they play a central role in developing complex software systems. C++ provides a ubiquitous syntax and semantics that is similar to other languages as well. Just to clarify the terminology, functions are subprograms that are not associated with a specific class or object. Methods, on the other hand, are typically associated with a class or object. However, typically, most people use these two terms interchangeably. Here's an example of a function. Every function has an initial data type that indicates the value that will be returned by the function or a method. Here in this example, the method returns a double or a floating point number. If this return value is void, then the method does not return any value but performs some logic when it is called. Each function or method can have 0 or more parameters. These parameters are essentially inputs and provide input values that the function or method can use to compute the final result. Each method or function should have a name. This name is used to call a method. In this example, the name of the method is area, and here in our main function, we use area and give it the value of 3 for the parameter radius to call this function called area. Each method or function has a body, and the body is placed between a pair of curly brackets as shown here. The body can contain any valid C++ statement, including calls to other methods. Before we delve into details of methods, we need to understand and review the concept of references. References are aliases or pointers, if you want to think of it that way, to variables. References are also used for parameter passing. Let's look at references through an example. Here, first we define a variable I, which is an integer, and the next line we define another variable called IR, which is a reference to the variable I. So notice how IR has an ampersand to indicate it's a reference. So now IR is a reference to I. Similarly, we can create references to objects. So here S is a string, and now SR is a reference to the string object S. Once we create these references, when we modify the reference, it actually modifies the object that it is pointing to. So in this example, when we modify IR, it actually increments the value of the variable I. Similarly, when we do operations with SR, it actually modifies the value of the object S that SR is referring to. So in this example, when we print the output, we get the value of 11 and S has 6 stars because we are indirectly modifying them through their references. So references are important and an integral concept in C++ and are heavily used for parameter passing when calling methods. Now let's look at parameter passing in a little bit more detail. Recollect that functions or methods play a central role in programming. So they take parameters or inputs for their operations, and the values that are supplied to these parameters as part of the function call are called arguments. C++ uses a consistent but very comprehensive set of conventions for parameter passing. The same conventions are used for functions and methods, so what we learn here are applicable to both functions as well as methods in classes and objects. And C++ provides consistent rules for both primitive and object types, so in that sense it makes life easier. This is different from other languages like Java that typically provide only one type of approach for primitives and a different type of approach for objects. In C++, there is a consistent approach for primitives and objects that streamlines concepts and their use. Let's look at parameter passing through examples. There are three types of parameter passing that we're going to look at. The first one will be passed by value, the second one will be passed by reference, and the third one is passed by pointer. Pass by value is typically used only with primitive data types. So for example, here there's a method called doIt that takes an integer I as a parameter, and here I is passed by value. So when we modify those local parameters, it does not affect whatever value that is being used as the argument. You can also use the const keyword with parameters. So here the parameter I is defined as constant, so we are not going to be modifying it. And in general, it's a good idea to use constants throughout your program in case you're not modifying parameters or variables. So look at some of the calling examples here. You can call the method doIt with a constant value like 5, or you can call it with expressions. The value of the expression is then computed and then passed as the argument to the method call. Or you can pass values of variables. Keep in mind here, you're passing a copy of the variable. Note that when you do parameter passing, you're passing copies. So when you send, if you use pass by value for large objects like vectors and maps, pass by value makes copies, and making copies can consume a lot of memory and use a lot of CPU and can cause serious performance issues. So be very cautious when using pass by value with objects. You can use it with objects, but just make sure that these objects are small and straightforward when you use pass by value with objects. The next type of parameter passing is pass by reference. This is the preferred way of passing objects to methods. So in pass by reference, notice that there is an ampersand next to the parameter. So here the string s is being passed by reference to the doIt method. Of course, you can pass constant references, and as always, if it is a constant, you will not be able to modify it. Now let's look at some example calls with references. So typically when you have a reference, you will create a variable to pass as part of the reference. So when you call this method, keep in mind you're passing a reference. So when you modify the value s in the method doIt, you're actually modifying the variable st in the main method. So make sure you have that conceptual mapping that you're passing a reference, and when you modify a variable in the method, you're actually modifying the object that that parameter is referring to. So this is an important concept to keep in mind. Keep in mind, since you're modifying the variable s in the doIt method, you will not be able to pass constant strings because the star here is a constant string and you cannot pass it because the method doIt is going to be modifying the string. However, notice that the out method takes a constant string as a reference, and the compiler knows that the out method will not modify the constant string, so you'll be able to pass a constant string to the out method. This is one advantage of using the constant reference, is that you can pass constant strings as well as pass variables, of course, to that method. Now let's look at pass by pointer. Here the parameter has a star added after it. Here that means you're passing pointers to the different values. Notice you can pass pointers to both primitive and object data types. And in case they are non-constant values, you'll be able to modify them like it is done in this example. Notice how we dereference these pointers to get to the objects or values in order to modify. So the code is written as star s to dereference s, the pointer to s to a string, and then add value to it. Same way you dereference I, and then add some number to it. So when we do these calls, this operates pretty similar to references. You must pass the address of the variables at the same time. So when you call doIt, you have to pass the address of I, which is what ampersand I means in that call, and the address of s, which gives you a pointer to s. So the addresses are passed to those two methods. Of course, calling doIt with literal constants is invalid because the method modifies it, and you will not be able to call the method with literal constants. In general, we will not use pass by pointer often. The only advantage of pass by pointer over references is that you can pass a null putter or a null pointer to those methods. With references, you will never be able to pass a null pointer. So references give you that extra line of defense where you can never get a null object, or you will never get a null pointer exception with references. So versus with pointers, you can get null pointers, so we'll use it very sparingly. Typically, you'll have to use pointers to interface with C libraries and often with the operating system. So only those are the situations where you typically use pass by pointer. Let's look at some rules regarding returning objects or values from these methods. In general, you should never return references to local variables from methods. Notice that here in these examples, the variable I and s are local variables. Returning references to local variables will cause runtime errors, and you should avoid doing that. Instead, you should simply return the values like it is done here. So if you want to return an integer, just return an integer. You want to return a string, just return a string. Of course, there is one case where you can return references. If your method accepts references, then you can return a reference to one of those parameters that you've accepted, and that will be okay. But returning references is still a very rarely used scenario, and you should typically revert to returning values instead. Now let's look at parameters that the main method can accept. So far we've used main without parameters, but main can accept parameters, and these parameters are called command line arguments. The reason it's called command line arguments are they are passed when the program is run. So the user can specify extra arguments when the program is run, and these command line arguments are passed to the main method. In C++, the command line arguments are passed with two separate values. The first one is called argc, which is the count of arguments, which tells you how many arguments are there in the main method. The second argument, parameter, is called argb, which contains a list of the actual command line arguments passed to the main method. So for example, if you run your program with the command line arguments 1, 2, 3, argv of 0, notice the second parameter to main, will always contain the name of the executable as typed by the user. And then argv of 1 will contain the first command line argument, argv of 2 will contain the second one, so on and so forth. Keep in mind, a program always has one command line argument, which will be the name of the executable in argv of 0. Typically, in order to have some useful command line arguments, argc should be greater than 1, and you can add checks for this in your main method if you wish. In order to process these command line arguments, it might be easier to make a copy of them in a C++ string and then use the C++ string for further processing. Also remember that all the command line arguments are always strings, so if you need to do some numeric operations on them, use the string to integer or string to double conversions to convert the strings to integers or doubles to do arithmetic operations on them. Alright, now let's review again the general rules of thumb for good C++. As a general rule, you will never use the new operator in C++. New is reserved for library builders, and as a rule of thumb in modern C++, if you use the new operator, you know you're doing something wrong. Always prefer to use the stream extraction operator greater than to read inputs. If you need a full line of input, use the getLine method, and of course use the std_quoted method to handle quotations. For output, use the stream insertion operator, less than operator, to print these values. Always use the standard comparisons both for primitive and object data types. This will make your life simpler as you go through and develop programs. And of course, keep the parameter convention in mind. Prefer to pass primitives by value. Keep in mind, pass by value makes copies, so if you pass large objects, you will incur memory and performance issues. So be cautious that one missing ampersand, one character, can make or break some solutions. Of course, when it comes to objects, so prefer to pass objects by constant reference so that you don't accidentally modify these objects in methods. So it's always a good idea to use pass by constant reference for objects. And of course, when you pass by reference, you don't make copies of objects, so you will not incur memory or performance issues. Alright, now that we have reviewed some more concepts, we still need to review a few more things before we are fully ready to develop complex programs. So we have already covered the basics of C++, and in this part we covered functions and methods. And the next set, we'll look at input-output operations using streams, particularly file input. And then we will review basics of containers like vectors and unordered map. And then we'll wrap the series with some introduction to object-oriented programming. Thank you.